Hi, I'm Casey Donovan, a student at Embry-Riddle University, and today I'll be talking with you about absolute hot and the Planck temperature. Now, before we get started on absolute hot, we're going to have to talk about absolute cold. Absolute cold is the coldest temperature physically possible, A0 on the Kelvin scale. For those of you unfamiliar with the Kelvin scale, it's just another way to quantify temperature, like the Fahrenheit scale or the Celsius scale. On the Celsius scale, absolute zero is about negative 273 degrees Celsius. Anyways, at absolute zero, the lack of temperature causes particles to stop moving. They just freeze. Now, I'm a sunshine and 90 degrees weather kind of gal, and I don't like thinking too much about an absolute cold. But absolute cold got me wondering, if there's an absolute cold, a limit to how cold we can get, does that mean that there's an absolute hot as well? The answer is, we don't know. The hottest temperature mankind has been able to reach experimentally is about 5.5 trillion Kelvin. Let that sink in. 5.5 trillion Kelvin, reached by the Large Hadron Collider, CERN, when they smashed together two particles moving at nearly the speed of light. To put this into perspective, the temperature of our sun, which is pretty hot, it's our sun. The temperature of our sun is about 5,700 Kelvin. Just 5,700 Kelvin. The temperature they found at CERN is over 900 million times greater than that. It's pretty hot, and yet scientists still think that there's a hotter temperature to be reached. This gets us to the Planck temperature. Now, Maxwell Planck was a German physicist whose theory on quantized energy not only won him the Nobel Prize in 1918, but also became the basis for quantum physics as we know it today. Planck's theory basically said that energy, specifically the energy of photons, came in not a steady stream, but in little quanta, like little tiny packages. And this is how Planck quantized energy. And by quantizing energy, he was able to quantize practically the universe. There's the Planck's length, Planck's mass, Planck's temperature, Planck's time. And these are the limits that modern science cannot go past, simply because we just don't know what happens. Which is why the best guess, or should I say hypothesis, for hottest temperature is the Planck temperature at 1.417 times 10 to the 32 Kelvin. That's 1.4 with 31 zeros behind it. I don't think that could even fit on the screen. Thank you for watching.